Yeah, let's graph some more quadratics. So in this video, we're going to talk about how to graph quadratics from vertex form. Previous video was standard form. I didn't mention this in the last video, but some people call standard form general form. I don't, but I've seen it called that before. Um, I have a note in here where it's referred to as general form, so I thought I'd bring it up. But let's talk about vertex form. So vertex form is when it's written in this style. It doesn't have all the A, B, and C like the last video had. It has an A. The B and C are gone, so we're not really going to find our A, B, C. But it has a H and a K. We're going to talk about what those mean in a second. And again, factored form will be in a different video. So this is the same info we had before, just to remind you. So it can be concave up or concave down. The axis of symmetry goes down the middle. Vertex, kind of interesting. Vertex might come up more here because we're talking about vertex form. So the vertex, you have the x-intercepts, the y-intercept. So the same, obviously the same characteristics we had in the last video because it's still quadratics. So nothing about the parabola changes. Um, so vertex form is right here. Um, it's when it's in this style. The A is going to affect the graph. It could affect if it opens up or down. It could affect where it is. The H and K are definitely going to affect where it is because the H and K is where the vertex is. So we'll see that in just a second. I don't want to write too much here because I think in the examples you're going to see exactly what I'm talking about. But basically, the nice thing about this, when you see a quadratic equation written in this style, we call it vertex form because they're just giving you the vertex. They're just telling you what the vertex is. So I will do a quick example of what it is. I'm not going to graph it, but I want to do a quick example. Let's say you had this as an example. Let's just say the A was 3 and you had something like this. That was your quadratic equation. Well, the nice thing about this is they're just telling you what the vertex is. The vertex is H and K. So I don't even have to do any work. The vertex is H and K. The vertex is 2 and 1. You know where the vertex is. You've That's a big part of graphing a parabola. We're not done, but we're practically done because you just know where the vertex is. So I like when it's in vertex form. Tells me where it's at. I like it a lot. So we'll see that down below. But that's vertex form. Standard form, we had a little bit of work to do, right? We had to find the y-intercept, we had to find the vertex using the formula, and go from there. Vertex form, they just tell you where the vertex is. They're just like, there it is, HK. So there's still a little work to do. We're not done because all we have is the vertex. There's more to do, but I'll show you. I will come back to this part. There's a reason I put this here. I'll come back to it. So let's just do two examples. Let's just see. Um, look at the first one. Um, do you know where the vertex is? Because I do. They just told us. So the vertex is at 2 and -5. And that's just where the vertex is. That's just where the vertex is. 2 and -5. So I can go put a dot right there at 2, -5. That's where the vertex is. Problem is, I don't know if it opens up. I don't know if it opens down. I don't know how wide it is. I don't know how skinny it is. So that's a little bit of a problem. So we have to do a little bit of work to find that out. Well, one idea I have is how about let's go find the y-intercept. The y-intercept is C, but the problem is none of these are C. That was just in standard form. Nothing was C. So um, but remember, to find the y-intercept, you just put 0 in for x. That's it. You just put 0 for x. That's it. So let's do that. So if I put 0 in for x, so I have a negative. I almost didn't see that negative. If I put 0 in for x, look, I just put 0 for x. That was it. And I can just figure this out. So 0 minus 2 is -2. -2 squared is +4. So -4 minus 5 is -9. So the y-intercept, I'll write that right over here. The y-intercept is 0, -9. That's a lot of info because it's right there. Look at that. I totally can see it now. The parabola would do this and that. Got it. I didn't draw it very well, but that's what the parabola does. Cool. Let's go do the next one. I know what the vertex is. Actually, this one's a little trickier. Um, I'll show you why it's trickier. But I do know what the vertex is. The vertex of the second one is it's not 1. It would be -1 because if you look at the formula, it's the formula for a vertex form. It is, look, it's -h would be a positive h. So this one, if you think about it, so it is a little trickier. There's not a lot of work to do, but it's trickier. If you think about it, this would be minus a -1 because that's what a +1 is. So the vertex in this case would be a -1 and 2, much like over here when I did -5. So it wasn't just 5, it was -5. But that's where the vertex is, -1, 2. So right there. I'm not done because I don't know. Does it open up? Does it open down? Is it wide? Is it skinny? I don't know. But I could use that same idea, right? All I have to do is is put 0 in for x. So that's kind of nice. Um, let's see what happens when I do that. If I put 0 in for x, let's see. It's not bad. I mean, I kind of like if you want me to find the y-intercept, I just put 0 in for x. I mean, there's a little bit of work to do, but it's not bad. Um, 0 plus 1 is 1. 1 squared is 1, so 3. So the y-intercept is going to be 3 right there. So that shows me it opens up. It looks like it's kind of wide. I mean, sure, I could be a little bit off on my graphing, but I mean, having those characteristics is, I mean, it gives me a definite idea where it is. I think I did a better job drawing this problem than the last one. The last one looked like a V, but I tried my best. Um, cool. So that's how you do it. When they give you a problem in vertex form, that's how you do it. Um, so not much more to it than that. Um, this thing I said I'd come back to, I'm kind of hesitant to do it because look, it's standard form, but I wanted to show you how standard form and vertex form are so easy to go back and forth. Because if you think about it, I could use this formula, negative b over 2a, to find the vertex. Then I could put it in vertex form. See, you see how those are connected? Because if I'm giving something in standard form, and I want to put it in vertex form, I just find the vertex and put it in vertex form. See, that's not too bad. I kind of want to do it just because I want to show you how connected they are. But I kind of want to pause because I want you to understand that, hey, we did what we said we were going to do in this video. We graphed things out of vertex form and we did it. But this is kind of a little bonus. I want you to see how standard form and vertex form are connected. So let me do this. So all this ugly thing here with all this info here is, is just saying, look, they give you a problem in standard form. Why don't you go ahead and do this work? This is finding the vertex right here. You do negative b over 2a, then whatever you get, you plug it into the equation, and then you get your h and k, and you're done. So that's kind of nice. I kind of want to do it. This is a problem we did in the previous video, so it's not a new problem, but I think it's a really good example. Let's find the vertex of this. So remember, the vertex is negative b over 2a. And remember, in this case, b is -4. So minus a -4 over 2a. Remember, we did this in the last problem. So what was it? 4 over 2, and that was 2. And in the last problem, we put 2 in there. I think we got -16 if I remember, but I'm going to do it. So let's see. We put 2 into here. We get 2 squared minus 4 times 2 minus 12. We get 4 minus 8 minus 2. Yep, -16. There it is. I remembered. So So you get negative 16. And so then now once you have the vertex, now you can just write it in vertex form because we know what the vertex is. So this right here is the vertex. So we know what it is. So now I can just write it in vertex form. So I like I had that problem from standard form, and I can just write it there. So we have the same a. The a is just 1. So I could put a 1 there, but I don't have to. I think it's a waste to put a 1, but I did it. So, and then the vertex is 2, negative 16. So we know it's h in the k like we talked about before. So it'd be x minus 2 squared. We know the k is negative 16. And there you go. And you could definitely graph that, right? You know where the vertex is. The vertex is at, just like we did before, but I'll just put the vertex on here. The vertex is at 2. Negative 16 is way off our graph, so I'm not even going to try to graph it. But we did graph this in the previous video. So, but I wanted to just like I wanted you to see how standard form and vertex form are connected. So, all right, guys, thanks. Take care.